Today we're going to be reviewing what we learned the day before spring break, and we're going to be physically looking at a one variable inequality, and we're going to be writing the graph that corresponds with that. So our first one here, we always start with simply writing our variable, and I'm going to use x today because it says this is our x-axis. So I start with my x. I then go ahead and I take a look at the arrow that is shaded. And as you can see, my arrow that is shaded is to the left. And I'm going to write the inequality that looks like that. And we know that to the left means less than. I then take a look at the dot. Now, if my dot is an open circle, then I'm going to keep it as is. It's either less than or greater than. However, if my dot is a closed circle, then I'm going to include that equal sign underneath. So it's going to be less than, greater, or equal to, and greater to. So this is a closed circle. So I'm going to write my line underneath. Basically, I write my inequality and then I see it's closed and then I add that additional equal. And then I simply write the number where the dot is located, and it's located at 6. And that's all there is to it. So the equation that goes with this number line graph is x is less than or equal to 6. So we're going to go ahead and do the same for letter B. I'm going to go ahead and start with my x. I then shade the side that looks like the arrow. We know that greater than is to the right. It's an open circle, and so I'm done with writing that inequality portion. That means that 1 is not a part of the answer. So 1.1 is a part of the answer. 2 is a part of the answer. 12 is part of the answer, but 1 is not. So that's saying I have more than $1 in my pocket. I couldn't just have $1 in my pocket. I have to have at least $1 and a penny. I then simply write that boundary point where the dot is located, and that is at 1. So the answer for B is x is greater than 1. Now, C is a little different because of the fact that we don't have arrows going. We have all of the numbers between 2 and not including 7. So the way that we do this is we go ahead and we write our x in the middle, and then we put a less than, and it's always less than on either side. I then take a look at the left dot. The left dot is a closed circle, so that means that the number 2 is included in the answer for this problem. So I'm going to go ahead and add that line underneath. The 7 is an open circle, so I'm going to leave that one as is. Now, all I have to do is finish up my problem by adding the boundaries. So my left boundary is 2, and my right boundary is 7. So what this is telling me is that all of my numbers that make this equation true are between 2 and 7, including 2, but not including the number 7. Okay. Same situation for this last one. We have it between two different numbers, so we put our x in the middle. We put a less than on either side. I see there's a closed circle on the left, so I add the equal. There's a closed circle on the right, so I add the equal. And then I go ahead and put my boundary numbers. My left number is -3, so I put that on the left. And my right number is -1, so I include that on the right. So this answer is all of the numbers, including between -3 and -1, including -3 and -1, will make that inequality true. So these are your answers, ladies and gentlemen. Let's go ahead and take a look at our lesson for the day. Today, we're going to be looking at graphs, and from those graphs, we're going to write our inequality, kind of the version of this, but with 2 variables instead of just 1 variable of x.